Hello, in this lesson, I'll show you how to use Excel to run a t-test analysis. In previous classes, I've shown you how to install the Data Analysis Tool Pak, which is an add-in that you can use to run statistical analysis. But before that, let me quickly explain to you what t-test is and what we use it for. Now, t-test is a statistical test that is used to compare the means of two groups. So when we have two groups of or two populations or two groups, and we want to test if there is a significant difference in the means of the two groups, then we use the t-test. It's often used in hypothesis testing to determine whether a process or treatment actually has an effect on the population of interest or whether two groups are different from one another. So basically, that is what we use t-test to do. Now, there are types of t-test that we have. Number one, we have the paired sample t-test. And in the paired sample t-test, the population are from, the samples are from the same population. That is, we are obtaining sample, we are obtaining two different samples from the same population. An example is if we are looking at the scores of some set of students in two courses. Probably we want to compare the performance of the students in two courses. Now, the same student will take the first course and the same student will take the second course, and then we compare their scores. So that is a paired sample t-test because we are administering those samples on the same population. And the second one is the independent sample t-test. Now, the independent sample t-test, the samples are from different population. The samples are from different population. That is, we take samples from population A and we take samples from population B, and then we compare the mean. For instance, we may say we want to look at the performance of students in mathematics department and performance of students in computer science department. We can allow them to take the same course, and then we compare their scores, the mean of their scores. Um, so that is an independent sample t-test because the two populations are different. Now, just like I've mentioned earlier, t-test is often used in hypothesis testing, and the hypothesis statement used to test used in t-test is there is no significant difference in the means of the two groups. That is, the non-hypothesis would mean that there is no significant difference in the mean. Don't forget, what we are testing in t-test is that we are comparing the mean of two groups. So the non-hypothesis will be that there's no significant difference in the means of the two groups. While the alternative hypothesis will be that there is significant difference in the means of the two groups. That is, the two groups have the same mean. They have the same mean. They are not the same, rather, sorry. That is, the two groups are not the same. Since we said there is significant difference, so that means the two groups are not the same. While the non-hypothesis, which is the H naught, would mean that the mean of the two groups are the same. That is, there is no significant difference. So in t-test also, we also work with the level of significance, or what we call the error margin, or the level of error. The level of error is the error margin that you are leaving out in the analysis. So if, for example, if you have a 5% level of significance, what you are saying is that you are 95% confidence that the analysis is correct, is okay. So that means your confidence interval is 95%. So level of significance is always determined by the researcher. It is always at the discretion of the researcher. And also, once the analysis is done, the decision rule in t-test is that you reject H naught if p-value is less than 0.05, actually 0.05 is the level of significance if you are using a 5% level of significance. If you are using 1% level of significance, the significance level would be 0.01. So depending on the level of significance you are using, that is um, how you will specify your decision rule. So if you are using 1% level of significance, then the decision rule will be you get H naught if p-value is less than 0.01. So let's go back to our Excel worksheet and see how we can perform t-test using Excel. All right, I'm back to my Excel worksheet now. So I have my data here which says score 1 and score 2. So we want to compare of uh, the mean of score 1 and also the mean of score 2. So how do we do that? We come to data, then click on data analysis. Make sure you install the Analysis Tool Pak. If you have not installed Analysis Tool Pak, please kindly check my previous video on how to install Analysis Tool Pak and do that. So once you click on data analysis, now you look for t-test. So here in Excel, we have like 3 types. We have the t-test paired two sample for mean. We have t-test two sample assuming equal variances, and we have t-test two sample assuming unequal variances. So depending on the type of t-test you are doing, if you are working with paired sample t-test, then t-test pair two sample for me would be appropriate. If you are working with independent sample t-test, then any of these is okay. So in this case, I will show you how to do the paired two sample for me, which is this paired sample t-test. So I click on this, then I click OK. Now, so once I clicked OK, then we have this dialog box coming up. We have variable 1 range and variable 2 range. Now, variable 1 range is the range of the first group, while variable 2 range is the range of the second group. So I would select the range here, the range of cell of for the first group, which is from A1 here down to A11. Then also for the second group, that will be from P1 to P11. So we have that already. Then it says hypothesize mean difference. Now, if you have an hypothesized mean, probably you already have a claim that the difference between this and this is a value. Probably you have claimed you have a claim like that. You can indicate it here, but in this case we don't have any, so we just leave it blank. Now, do we have labels in our first row? Yes, we have labels, so we click labels. Now, alpha, like I've explained to you previously about level of significance or error margin. Now, this alpha here is asking you which level of significance do you want to use. Now, here we have 0.05. You can change it. If you are using 1% level of significance, you can change it to 0.01 as you wish. But in this case, I would want us to leave it to 0.05. It is 0.05 by default. So that means we are saying that we are leaving a 5% error margin, and that means we are 95% confidence about the result. So the next thing is the output options, and then I click output range because I would want the result to be on this exact worksheet. So once I click on this, select the where I want it to display, I just click it on the cell, close this. Then the next thing is to click OK since everything here is set. So I click OK, and here is my result. So basically, let's discuss this result. Now, the first thing you would see is the mean of score 1 and the mean of score 2. Now, if you notice, the mean of score 1 is 32.3, while the mean of score 2 is 30.2. And then the variance for each of the scores, this is variance for score 1 and the variance for score 2. And these are the observation And this is the Pearson correlation, that is the relationship between score 1 and score 2. So now this value shows to us that there's an inverse relationship because it's negative, negative 0.4064. So it shows an inverse relationship between score 1 and score 2. That implies that as score 1 increases, score 2 will decrease, and as score 2 increases, score 1 will decrease. However, you will notice that the relationship is quite weak. Now, hypothesized mean difference is we did not specify any mean difference, so we just leave it at that, and the Z gave us 0. Now, the degree of freedom is 9. That is the total observation, which is 10 minus 1, give us 9. Now, here is the T calculated. This is a T calculated value here, 0.660, and then we have the P value for one tail. Now, I will discuss later the difference between one tail test and two tail test. Just watch out for my video on that. Now, this is the T critical, that is the critical region for one tail. And then this is the P value for two tail and the critical region for two tail. Actually, there are two ways you can make your decision here. Just like I've showed you the other time, we have a decision rule which says reject H0 if P value is less than 0.05. And don't forget, this is our P value for two tail, this is our P value for one tail. Now, for the purpose of our hypothesis statement, we'll be using the two tail test. So there are two ways you can make your decision. Number one, you can compare T start with T critical. If T start is greater than T critical, you reject H0. And alternatively, you can use this decision rule here too, which says reject H0 if P value is less than 0.05. So here you will notice this is a P value, 0.525 is not less than 0.05. That is, this value is greater than 0.05. This implies that we would not reject H0. We would not reject H0. Now look at this. Let's use this T start. If you compare T start with 2.26, which is the T critical, you would notice that T start is lesser than 2.26, so we reject H0. So once we reject H0, what does that imply? That implies that we are rejecting this non-hypothesis and we are accepting this. So that means there is pardon me. In this case, we are not rejecting H0 because this T start is less than 2.26, so we are not rejecting H0. And here too, you will notice that this value is greater than 0.05, so we are not rejecting H0. So if we are not rejecting H0, what happened? That means there is no significant difference in the means of the two groups. So this implies that score 1 and score 2 are the same. There's no significant difference in their mean. So basically, that is what we use t-test to do. We use it to compare two groups, to compare the mean of two groups. So the same thing, the independent sample t-test and the paired sample t-test, the same way they work, only that in independent sample t-test, the population are different, while in the paired sample t-test, the samples are from the same population. So that is that about t-test. In the next video, I'll show you more statistical techniques that we can perform using Excel. Thank you.